Let's talk about one of our favorite topics, money. Money has three basic functions. The first is a medium of exchange. Imagine if we didn't have money. How would you get what you wanted? Well, probably you would trade. But think about how inefficient that would be. Imagine that I was the village canoe maker, and I decided I wanted chicken for dinner. Well, how would I go about that? Well, I'd make a canoe, and then I'd take the canoe around town, and I'd try to find someone who had a chicken. You can imagine me carrying the canoe on my back, knocking on doors. Hey, do you have a chicken? Hey, do you have a chicken? Finally, I find someone with a chicken, and I say, well, you have a chicken, I have a canoe. Would you like a canoe can I give you a canoe for your chicken? And then they say, no, I don't really need a canoe today. And then I continue on my process. You need what's called a coincidence of wants, meaning that I need someone to find someone who not only has what I want, but wants what I has. And if I had to do that all day long, all my time would be spent trading and not very little time producing. When you have money, I can sell my canoe for money, and then I can use that money to buy a chicken or a steak or whatever I wanted to eat that night for dinner. Money becomes a medium of exchange instead of exchanging things directly. The second function of money is it becomes a store of value. Perhaps you don't want to spend all your money right now, all your value right now. Well, money, you can save it you could save it in a piggy bank, you could save it at the bank, you could save it a lot of different ways. Dollars are not the only kind of money that's used as store of value. Things like gold, even art can be used as store of value as well. It's when you want to save the value until later. The third function of money is it becomes a unit of account. If you've ever gone shopping for a big item like, let's say, a TV, you probably didn't walk into the first store and just buy whatever TV they had there. Probably you did a little research, you found the TV that you wanted, and then you went to different stores to see where you could find that TV for the lowest price. Money allows us to do this because the TVs are all expressed in the same terms, in the terms of dollars. If I went to one store, if we didn't have money and instead we just had trade, and at one store I went there and they said, well, a TV is worth 6 chickens. Cost 6 chickens. And I went to another store and they said, oh, for a TV we want, half a cow. I don't know. I know it's kind of ridiculous. But I would have no way of really knowing which one was the best deal. But if I can have a common unit of account, then I can easily compare the value of one thing to another. Money works best when it has several characteristics. First of all, it needs to be portable. Something we can carry around with us easily. That's why gold bars didn't last very long as money, because it's not very portable, it's very heavy. It needs to be durable, it needs to last. If you've ever washed $1 in your washing machine in mistake because it was in your pocket, you know that our dollar bills are very durable. If I wash a receipt or another piece of paper, it disintegrates, but a dollar bill doesn't. It's been made durable because it has linen inside of it. The third characteristic, it needs to be divisible. You need to be able to make change, basically. It also needs to be acceptable, so other people need to agree that it is worth something and be willing to accept it for goods and services. And it needs to be stable, meaning that we can't use something that all of a sudden more will appear on the market, just decreasing its value. What is it that actually makes money valuable? Well, when we're talking about the dollars, what doesn't make money valuable is gold. Our dollar is not based on any kind of gold standard. In fact, our dollar is valuable just because the government says it is, and because we accept it. In a way, our dollar is backed by faith. This is called a fiat standard. In this case, money doesn't represent any type of actual real commodity or real item, but because it is limited and is endorsed by the government and people accept it, it is valuable. That's why I can go to Kroger's and I can give them $1 and I can get a candy bar. There are different ways of counting our money or looking at our money supply. We have two basic definitions. We have M1 and M2. M1 includes all the money that we use as our primary methods of medium of exchange. This is the money you use every day. This is your currency and coins. This is the dollar bills, the $5 bills, the quarters and nickels and dimes, all those kinds of things are part of M1. Also, all the times you use your debit card and you get things out of your checking account, or you write a check. These are things we use in the medium of exchange on a daily basis. This is the most liquid form of money. A little less liquid is M2. M2 serves as a store of value. It's money that we kind of keep for a little bit later. Now, it does include M1 because you can, of course. I could keep my money, my cash, and save it for later. But it also includes all time deposits, whether it be a savings account or maybe a money market deposit account or money market mutual fund or a certificate of deposit in which I keep my money in for a certain amount of time. In the United States, the Federal Reserve is the sole issuer of currency. And so who controls the supply of money is purely the Federal Reserve. Let's talk a little bit about the time value of money. Is a dollar today worth more than a dollar tomorrow? Yes, definitely. There are two reasons, and that is opportunity cost and inflation. Well, opportunity cost means that every time I don't spend a dollar, and I save it for later, there are things that I'm giving up, things that I'm not spending it on, and those are what we call opportunity costs. Inflation is decreasing the value of my money as well. So let's see how this works. Let's look at a simple interest formula. You've probably learned this in math class before. In this formula, V is the future value of our money. P is the present value. R is the real interest rate. Now, to determine real interest rate, that is really simple to do. It's the nominal interest rate minus the inflation rate. And N is the number of years. And so if you see it's V equals 1 plus R to the nth times P. And so if we take this and see how it works, let's look at a question. Assume that inflation is expected to be 3% and that the nominal interest rate on simple interest savings is 1%. Calculate the future value of a dollar after 1 year. So let's say we expect inflation to be 3% and we're going to earn 1% on our savings. How much money is our dollar going to be worth at the end of the year? Well, I bet just looking at that, you can see that it's not going to be worth as much at the end of the year as it starts out. Well, first we have to calculate the real interest rate. That's step one. The real interest rate is the nominal interest rate minus the inflation rate. So it's 1% minus 3%, which equals 2%, or negative 2%, or negative 0.02. Step two is to use a simple interest formula to calculate the future value of a dollar. So let's zoom in on this a little bit. And so we take R, we just said, was negative 0.02. The number of years is just 1 year times a dollar. And so we finish out the calculation. We see that at the end of that year, a dollar will actually only be worth 98 cents. Well, how can that be? How can a dollar be worth less than a dollar? Well, the idea is that we're measuring in terms of what it can buy, because that's all that matters. A dollar means nothing unless you can actually spend it on something. And so while at the beginning of the year you could buy a dollar's worth of product, now you can only buy 98 cents worth of product. Next, let's talk a little bit about something called the monetary equation of exchange. This equation was developed by Irving Fisher, who says that nominal GDP is equal to our money supply times our money velocity. So now what we're doing is taking the concept of GDP that we've already learned, which is basically our national income, right? It's our C plus IG plus G plus XN. It's all the goods and services that are created in a country in a given year. And that nominal GDP, that means GDP in the current year's prices, is equal to how much money we have out there in the economy times how much the money's velocity. And the money's velocity is how many times that money is spent in a year. So a single dollar, like you might look in your wallet and see a dollar. How many times has that exact dollar been passed around from store to person, just being spent on things throughout the year? And so the idea behind this is that if you change even the money supply or the money velocity, you can change the nominal GDP. The equation, or the monetary equation of exchange, is M times V equals P times Q. M is the money supply, V is the money's velocity, P is the price level, and Q is the real GDP. And remember, the real GDP has been adjusted, right? So if we times that times price, that makes it nominal GDP. So M times V equals P times Q. Let's look over at our graph that we have learned before, and that is our aggregate demand and aggregate supply graph. And you see, if the M1 is $2 trillion, and the velocity of M1 is 7, so a dollar is being spent 7 times, then that would mean that our GDP, our nominal GDP, would be $14 trillion. Let's look at a few sample questions that you might find on the AP test regarding these concepts. In the equation of exchange, if V is constant, an increase in M will necessarily increase which of the following? A, the velocity of money, B, nominal GDP, C, the demand of money, or D, government of spending. Well, this is simply a math problem, really, when you look at it. The answer is B, because if V remains constant but M changes, we know that PQ will have to change as well in order to balance the equation. The next question. Assume that the United States economy is in a long-run equilibrium with an expected inflation rate of 6% and an unemployment rate of 5%. The nominal interest rate is 8%. It asks us to calculate the real interest rate. What was the formula that I mentioned earlier to figure out what the real interest rate is? It's the nominal interest rate minus the inflation. So even though we've been given the unemployment rate in there, that's not something we actually need right now. So let's take 8% minus 6%, and so the real interest rate is 2%.